Hello all. I will be doing a problem on forecasting today.
Using the 5-week domain numbers for Trojan genes, we have to forecast the week 6 number of genes and the mean absolute deviation using the moving average forecasting method, as well as for problem 13 using the exponential smoothing method.
In problem 12, it asks us to calculate the moving average for week 6. That involves taking the last 4 weeks of data and averaging it out to find an expected value for week 6. To do that, we take 34 plus 50 plus 10 plus 25 divided by 4, which gives you 29.75. To calculate the mean absolute deviation, we have to take the expected value for week 5 and subtract it by the actual value of week 5, since that shows us the actual deviation. We can only do it for week 5 since you need 4 weeks of data and we don't have the data for the actual results in week 6. Therefore, our mean absolute deviation is 28.5 minus 25. The absolute value of that equals 3.5. So in exponential smoothing forecasting, the formula we use to forecast future periods is alpha, which is the parameter 0.3, times the actual demand in the present period, plus 1 minus alpha times the forecasted demand for the present period. The sum of those two numbers equals the forecast for the next period. So when we start doing the calculations, for the first week, we don't have a forecast because there's no previous weeks to base it on. In this case, the forecast and the actual remain as 20. So we put 20 as the expected value of the second week. From then on, we'll use the formula as 34 times 0.3, which is the smoothing parameter, plus 1 minus 0.3 times 20. When you do that, you get 24.2 for the forecast for week 3. When you repeat this process, you get the following numbers. So our forecast for week 6 is 25.25 genes. And the second part of the problem, which is calculating the mean absolute deviation, to solve that, we take the expected value subtracted by the actual value for the week, take the absolute value of that, and add up all the weeks we have forecasts as well as data for. So we do 35 minus 20 plus 24.2 minus 50 plus 31.94 minus 10 plus 25.36 minus 25, and take the average of that, which gives us 15.52 for the MAD. And that is the full problem for 12 and 13.